just sort of sit in my grade book, which some of you that have a very high A, or I probably didn't put any bonus points in because if you don't use them this semester, they carry over. They're like carryover. I don't know. People don't have cell phone plans so much that used to do that, but when we used to all not have unlimited, there used to not be such a thing. You would have a certain number of minutes that you could talk on your plan that you paid for. And say if it was 7,000 minutes, and if you only talked 6,000 minutes, you'd have rollover minutes that would go to the next thing. Anyway, I don't know if y'all knew about that. But, so anyway, they're your bonus points. You could end up at the end of the year with bonus points that you never needed. And that's great. I have insurance that I pay for every month, and I would love not to need it. You know, like I want to have it for insurance, but I'd love to not have a wreck or a sickness or something where I do need my insurance. So that's like your bonus points. Okay, they're insurance in case you need it. But as each semester ends, I don't care so much at interim grades, especially, I mean, for seniors, I'm a little more careful because they might be going to colleges. But for you, I just wanted to give you a gauge of where you are right now. And so most everybody I took, if you did the bonus project, I probably just threw it in one of the two tests and it brought up your average, and I was happy, and I, you know, hit the button to let them know that I was finished. I'm a little more careful as the semester and your grade really goes in. So and I'll tell you what your averages are. I mean, you know, sometimes people will email me toward the middle of December and like, what's my average, so that you know what you have. And I would love for you to ask me, but if it's like a 96.2, it kind of doesn't matter where your bonus points are, okay? But if it's a 94.2, you might want me to take the bonus points out of the test I put them in and see what happens if I put it in another test, because they're your bonus points. And so if that pulled it up to a 94.5, then that would make a difference. And so I would say that's on you to meet with me after you find out your average as we get to the end of the semester. And for a lot of you, it's not going to matter. You know, if you have a 86 average and you have, 87 average, that's a B plus. Your bonus points aren't going to pull you up to an A minus. Bonus points are not going to pull you up 3 points. So, but I don't mind looking at it with you, but do you see, for a lot of you, it's not going to be a big discussion. But I just want to make sure that you know that. So some of you may not even know how many bonus points you have. So you can also meet with me to ask about that. There's so many of you, I don't want to get any more into it right now. Okay, so it's interesting walking around the room. Every year when I hit inverse functions that we're going to get into in just a minute, and when I first give the first sheet and say do it on your calculator in degrees, I love how some of you are so thoughtful and intelligent that you don't trust your calculator and you override what it says. Some of you, I think a lot of people just don't understand what their calculator's saying, and they think, well, you know, in the past, sometimes myself and other math teachers will go, well, you've got to have the brain. You can't totally trust what your calculator's saying, which is entirely true. But there are correct answers to these problems, and I will tell you what they are, and then I'll tell you why. Okay? For some of you, it'll be a little bit upsetting, but I will tell you why it happens. Okay? I'll explain it. The whole class will be spent on that. So hunker down and listen up. All I'm going to do right now, in light of the people I've met with, or that I've seen meet together with their friends at the board on the Math Center, so many people have got these bicycle problems down. They can go and go and go. Some of you got the first one because you followed what the video said. And you haven't maybe really processed and taken ownership of it. But there will be one on the next test. And so you ought to be able just to knock it out. There'll only be one, but you don't know if I'm going to tell you how fast they're pedaling, which is angular velocity, or how fast they're going, which is linear velocity. One thing Lindsay and I talked about this morning that a lot of you are realizing that I had to realize, it's kind of interesting when we say how fast are you going, we're always talking about linear speed, okay? So we're not talking about, we rarely talk about what's super important, like how fast something's spinning and how big it is, contributes to how fast it's going. So we have to say words like how fast is it spinning is theta. How fast is it going is s. Two objects can be going the same speed, but one could have to maybe be spinning far faster than the other one. Two objects could be spinning at the same rate, but not going the same speed. Okay, so if you imagine this is 30 miles, and in an hour, both objects went from point A to point B. They both went the same speed, 30 miles, they covered 30 miles in an hour, okay? But you see the angular velocity of one might be greater than the angular velocity of the other. What's the only case that wouldn't be true? How can they have the same angular velocity and the same linear velocity? They're the same size. They got the same radius, okay? So we'll have a couple of people call out their answers. And if you didn't get these answers, or you still feel like you're not going fluently through this, please meet with me, because everybody that's met with me today, I think, or yesterday, could say, if you didn't already get it, that you get it, and that you feel like you could do any one that I give you. We want to get you to that point. And they're not scary anymore, okay? They were scary at the beginning, okay? The first one was 168.068 revolutions per minute. And one thing to think about, that a whole lot of people contacted me. I love the thought process. You should always be this person. When we probably won't do this year because our class is so big, but lots of years I have what are called career projects, and people, like, you get in groups and bring people in from the outside to come talk to us. And quite often people from out there doing a real job, they so often, like, please give us somebody that has number sense. Like, this person just quoted this project that they could sell for $4 million, and there's no way it costs that much with the components that the person put together. A lot of y'all got, like, either an extremely big number or an extremely small number, and you knew something was wrong. Also, if you merge it with the 40 miles per hour, we got 192, I believe, 0.077 or something RPM. All right, so if I'm going slower, I should be pedaling at a slower angular velocity. And then to fast forward to number 2, where it was going 120 RPM, it's a lot of ratios, which a couple of people have brought up, and that are doing this by ratios. And that, Isabel, you brought that up to me last night. There are some people that can do this with ratios, and they do it faster than I do it. Is anybody doing it with ratios?
Well, I checked it with the ratio.
Okay. Yeah, so you may want to meet with them, because if they're getting it right and you're going the ratio route, because she was absent the other day, so her brain was automatically thinking ratios. But just land on one, don't, okay? If you're going 120, you should be going less than these two, right? And it was 24.98, like 989. The next number was also 9, I think, miles per hour. One thing that some of you are seeing is that why I don't do anything till the end. Almost all of you now are following my lead, where you keep up with a bunch of the numbers, so you're not struggling with all these crazy decimals, and we'll all get the exact same answer at the end. You can give me truncated or rounded. If you started rounding that, I think it would go all the way up to 25 miles per hour, and I would accept that. Because the next number there was a 9, which would round that 9 up, and it would just tumble over to 25. So those are the answers. I'm going to talk about it briefly, and then we're going to move on. If you don't get it, meet with me sometime before November 22nd is our next test. It's already on the testing calendar. Mr. Hill and I checked, and we're not encroaching on the 2 tests per day for junior rule, okay? So, well, they haven't put it on the calendar yet.
We have a Spanish. It's a Friday. And we have a physics test. It's a Friday.
Oh, it's next week?
It's a Friday.
Yeah. So it's next week, okay? They're not on the calendar, so ours is on the calendar. Are we okay, Mary? Did you figure it out? Okay. So test November 22nd. So if you know for sure that in our class we'll have one of these. Mr. Hill's class has done other interesting things that, our tests maybe have 20 problems where 18 are the same and 2 are different, okay? And so far I've actually probably written the first draft of both tests that you've seen. And so you know that I like doing it, and then he takes it and tweaks it for his class, and vice versa. Sometimes when we're teaching together, he writes the test and then I grab it and tweak it for you to where it makes sense. Anyway, we're both doing thought-provoking application problems. And So anyway, let's move on from that, and let me talk about just briefly if a bicycle's going with your little apparatus. Okay, if I tell you that that's like my extent of a bicycle, there we go. Okay, so if I tell you how fast the bike is going in the S equals R theta scenario, you know, with a few people I met with yesterday and this morning, I said, let's write down S equals R theta for every wheel, okay? And which wheel does that pertain to? The tire, the wheel sprocket, or the pedal sprocket? All right, so the wheel is yellow, the wheel sprocket is red, and the pedal sprocket is green. If it's going 42 miles per hour, first of all, is that an S, an R, or a theta? It's an S, okay? It's a speed. It's like that line that I keep pulling out of the tape. Linear velocity is what we usually refer to as speed. Speed is S, okay? And which tire is it, which wheel is it referring to? The yellow one, right? So that's how fast this bicycle's going. So you know S, and you know 14 inches, and you can find theta. Once you know theta, then you know the theta of the little red one. So now you know theta of the little red one, and don't you know the radius of the little red one? So then you'll know S of the little red one. You'll know the arc length of this. And don't they share arc length? Whatever's going around like this, okay? Or so they share that line that's going through them. So when I get to the green one, the pedal sprocket, S equals R theta, I will have just found S that I can put down here. That's a great way to do that now that I think about it. All right, so we'll kind of go both ways. It was interesting, so many people realized that they did want to go backwards on these. All right, so starting over. 42 miles an hour is this S. You already know the radius, so you can use that to find theta. Theta goes now to the wheel sprocket, in which case you know the radius of the wheel sprocket and the theta of the wheel sprocket, so you can find out how much chain it's going through. And so you've got S, which is also the same chain that's connected to the pedal sprocket, where you're going to know what on the pedal sprocket, you're going to know R. You will have pulled this S in down here, and so you can find theta, which is how fast you're pedaling. That's your angular velocity, except for it will come out of the formula in radians, and you probably will have to convert it to what? Revolutions. RPM, you know, like I talked about, there's so many things in life that are revolutions per minute instead of radians per minute. Okay, now going backwards, if I tell you how fast you're pedaling, then you know R and theta of the pedal sprocket. You can use that to find S, which black's not a great idea here. You can use that to find S, okay? Once you know S, it's the chain that's connected to the little wheel sprocket, where you will know the radius of the little wheel sprocket. If you know S and R, you can find theta. The wheel sprocket and the tire are going at the same, spinning at the same rate, and that enables you to go R and theta to find out how fast the thing is going. So it's an ultra composite function if you remember f of g of x. This is like an f of g of h of x. Find one thing, put it in, find another thing, put it in. If any of those are wrong, it's going to mess up your final answer. All right, now, if I get this, and I put this on it right here, I wish it would like actually fit. It wouldn't fit. But here we go. Okay. Now, if I bolt those together like this, once the big one starts to turn, or the little one starts to turn, you see they're turning together? They're going the same angular velocity. That's different than if I taped them together. As this one spins, this one's not spinning at the same rate. You see, it's very different being chained together than being bolted together. Okay? So it's very like the playground equipment that I've talked about. If you're on the outside, if you've been on one of those things that somebody spins it really fast, or you've been at the fair, they put you on the outside of those centrifugal force rides. That's where you're going to feel it. If you move in closer, you're not going to be going as fast. You'll be revolving as fast, but you won't be going as fast. So I mean, I've tried and tried, and so maybe a 101 if you still need help, see me about that. One thing that I was going to get Lindsay to remind me of that I just remembered is some of you have seen these, which is ancient, but it's sort of funny how things come back around. All right, so these are 45s. Like back when your grandparents were probably, and teenagers, not even your parents, people would go and buy these in the stores instead of download some music in their iPhone app, okay? So anyway, there's 45s, and a lot of you at least kind of know what they are. They're smaller. They go 45 revolutions per minute. They're 45 RPM, okay? The albums that have lots of, these are singles. You can say it now. Somebody's released a single. Like Beyonce's released a new single, but it's not really one piece, but that's what they mean. That's their new song. You would go, I don't know, Elvis's new songs. You would go and buy Blue Suede Shoes, and you would only have that song on that record, except there'd be also one on the
Is that a
back.
fun fact?
Yes, please.
My great uncle, well, he's still alive, but he was Elvis's recording engineer. So he lived with him at Graceland.
So he what?
He lived with him at Graceland. Because they would just record whenever.
Lived where?
At Graceland, that's what we call it, right? Yeah.
Yes, and he worked at Sun Studios. I'm sure he worked at Sun Studios probably.
Yeah, and then he was also
You need to
recording,
go to
like,
Graceland.
Hairspray and
It's
stuff.
amazing. Graceland's
So,
amazing.
like, a lot of times, like, Elvis, like, things will, like, interview him. It's cool.
Oh wow. Man, that is so cool. I want to
Yeah,
find
these
out
are
more
cool
about that.
stories.
Yeah, it'd probably be a great career project. Maybe I'll assign him as bonus next year, and you can interview him or bring him in. That is so cool.
Yeah.
Oh my gosh, I could talk to him for hours. Okay, I'm just being from Memphis. So here's an old record player. There's a really old record player. Let me see if I can find the knob I want. I need like a top view. You might could see it here. This little button, I wish you could see it better. Oh, there we go. Well, you can't really see it. That little knob would turn to 45 and 33 because the big album spun 33 revolutions per minute. If y'all know enough about record players, you know you pull this little needle and put it on there. That's its S. It's just sitting there as it's doing a linear velocity. Based on that angular velocity of which one you film, you know, when your parents were little kids, they probably would put or maybe your grandparents, you know, you probably maybe even know this would happen, you may have heard it yourself. If you put a 45 on a 33 and you don't turn the knob to whichever record, it'll sound like the Chipmunks. Or it'll sound like, ooh, slow. It'll be really funny. So if you've got it on the wrong speed, it won't sound right. But that was all what we're doing today. It was built into a record. Okay?
Could you tell what happens when it's too slow again?
No.
You get it?
No.
Okay.
No. We'll practice a song and sing it for them really slow. Okay, so moving on to inverse functions. All right, so I'm going to closely follow my notes here. See, who else is absent? Katie. I just feel like I left her test laying around somewhere. Maybe it's over there. All right, so raise your hand if you play a sport. Okay. All right. Lily, what sport do you play? Swim. So she swims. So I said Lily. She swims. Raise your hand if you swim. All right, so only 2 people. All right, so Danielle also swims. I think we know there's a lot more people on the swim team, right? Okay, so raise your hand again besides swimming. Raise your hand if you do. Raise your hand if you do winter track. Because okay. All right, so Mary, what sport do you do in the winter? So she does track. All right. So Grace, you do track. All right, Lauren, you do track. Lord willing. Isabel, you do track. Katie? Katie does track?
Yeah.
Okay. I'm trying to remember what did I miss anybody on track? Winter track. Okay. All right. So if I say, Katie, what do you do? And she'll say winter track. Okay. Now, what if I go the other way with it and do the inverse function? And I say, who runs track? And I just go, Katie. We all of a sudden have a problem. Because how many people do I have to list for my inverse function? A bunch of people. Do you see that it presents a problem? Okay? Because really and truly, I remember thinking, I don't know if you think this about your parents, but I remember thinking about my parents. It would aggravate me so much. I'd get in from a party or something, and I'd go, who was there? And I know they were just being nice, and it would have been very kind of me just to not sigh and go, do you want me to list everybody and then be put in my room for the next 5 days? But anyway, you know that feeling like, I'm sorry, maybe I'm just that way and I'm super nice, so I gotta think y'all were that way too. But who was at the party? And I didn't need to do the snarky, well, do you want me to list everybody? They just wanted to know, did I have a good time? And I could have said, so and so and so and so were there and we had fun, but it was, my father's a mathematician, and so he should have known better, like who was at the party. Well, how long do you have? There were 150 people at the party, let me list them all. Whereas he could have said, was Helen at the party? Yes. Okay. So let's do one more thing just to kind of set it in stone. I'm gonna still pick on Katie, okay? Because Katie runs track. And so it's really easy for Katie to answer the question. I could go, Grace, what sport do you do in the winter? She would say track. Not difficult. If I say, who runs track? All of a sudden, you want to name the people in here, then you got to ask me, do I mean the whole team? Do I mean indoor track or, well, probably we'll just say winter track. But y'all see the dilemma. Or you can even ask me, I can say, Grace, what sport do you do? And she would say, running. And then I say, who does running? Your questions then become, do you mean just at Marymount? It becomes a huge question to turn the function around, okay? All right, now, so Katie, what school does your sibling go to? What college?
Boston.
Okay. Now I go, who goes to Boston College? Comma, fill in the blank. I don't know how many thousands of people go to Boston College. Do you see that's ridiculous? It's a problem. You've got to now struggle and clarify. Do you mean from Marymount? Do you mean from New York? Do you mean in the freshman class? It's not near as easy as when I switch it, the X and the Y. One more scenario that happens in here. I have Grace Murray, and I have Grace. I always forget if it's Hooper or Hopper because of that astronaut lady.
Yeah,
Hooper. Okay, I got to get that straight. But, it could be worse things if I compare you to an astronaut lady. Okay. So Grace Murray and Grace Hooper, okay? So if I say later on in life, if you're, and I tell you this is really kind of a bad example now that I think about it. Because right now, it doesn't function very well. Because I have to go to look at you and go, Grace, or I have to call you by your last name, or let you both answer and wonder who I'm talking to. It's not wrong for them to be named Grace, one of my favorite names, by the way, but it doesn't function very well. Do you see that's not a function? A function is every X has only one Y. But these, the X's are repeating, like the vertical line test. Now later in life it's going to function really well if it's Dr. Hooper and Dr. Murray. Then we're going to know who we're talking about, right? They're in the same hospital and somebody goes, Dr. Murray, come to, they're not going to wonder who they're talking to unless there's another Murray, then that's going to be confusing, okay? okay?
Megan.
Yeah, so you're starting to see, there's nothing wrong with it, but it can be confusing, okay? So where the confusion sets in is a function if we have, sorry, I'm trying to just scroll up and I'm like stuck in this, here we go, I just do it over here. All right, these are a function. Thank goodness, because Grace Murray doesn't apparently, you don't run track? Oh, because then it wouldn't have functioned, because I'd have Grace track, okay? So do y'all agree this is all a function? I could go, Lily, you swim. Danielle, you swim. Mary, you run track. Grace, you run track. Lauren, you run track. Isabella, you run track. Katie, you run track. If I change the x and y, it becomes very confusing. The inverse is not going to be a function. Because I would go track, comma, Mary, track, comma, Grace, track. Do y'all see what I mean? The inverse of that is not a function, and that means life all of a sudden gets very complicated, okay? Or somewhat complicated. Y'all see what I mean? So what Grace is to realize that some of y'all are laughing about is right now it's confusing because of her first name. Later on in life, there could be a couple of Murrays, and that's confusing because of her last name, okay? So, you know, I guess there's probably some other Becky Laziris in the world, but, you know, it's not super confusing because my name's kind of weird. All right, so back to this. Oh, that's how much that her little sister
Wait,
looks
that's
like
her
her.
little sister?
Yes.
I thought that was her.
Yes, is that scary? Okay. All right, so I'm going to ask you another question. What is negative 4 squared? 16. Okay? Then I'm going to switch it around. What do you square to get 16? Okay. Uh-oh. And then you're like, which one do you want? Do you want me to give them both to you? Well, you don't do that if you're naming a point. Which point do you want? Watch what they decided, girls, to start to see this. The x squared function looks like this. It is a function. And your Algebra 2 teacher probably said this word to you, but it's not what we call a one-to-one function. A one-to-one function passes the vertical and the horizontal line test, the first and last name. The only way that our lives are not going to be confusing is if every single person did a completely different sport, or if every person had a completely different first and last name, then it would not be confusing, okay? So as I go up here, do you see how that flags for me? In fact, it's like this, girls, like people in the video can't see me do this, but a horizontal line test is a precursor to the inverse function. It's like you're turning your head. You go, well, what's your y's? Are you going to, when I change my x's and y's, are you going to pass the test? Do y'all see how I'm doing the vertical line test is testing my x's? When you take an inverse function, I think you all know from Algebra 2, you switch your x and y, right? Okay. When you switch your x and y, do you see how that's a precursor to see if everything's going to be okay? These y's are about to become my x's, and you see that won't work? It's not going to be a function. If I actually took the inverse of this yellow graph, it would be this white graph. And this can be very eye-opening to a lot of people, so listen up. It would look like this. Inverse functions flip over the line, y equals x. Makes sense because you're switching the x and the y. What was up here, maybe 2, 4. That would be negative 2, 4, I'm sorry. Negative 2, 4 has become 4, negative 2. Do y'all see what I mean? Okay. Is this second one a function? The yellow one is a function. Is the white one a function? No. But I knew it wasn't going to be because, do you see it wasn't one-to-one? Okay? So there's functions and then there's one-to-one functions. All right, so to move ahead, what's interesting is you learned in Algebra 2 also what the x squared graph looks like. But you also learned what the square root of x graph looks like. It just looks like this. You don't get the whole thing. You only get part of it. Like this, we've talked about this a little bit in my class earlier. The square root of 16 is just 4. Remember how we talked about that? If I want you to say negative 4, I've got to talk about the negative of square root of x. Do y'all see what I mean? And I can talk about this one, it's a function, or I can talk about this one, it's a function. But I don't get them together. I don't get to have them together. So all of a sudden, I hope you're starting to see if it's not one-to-one, we've got to find some workaround. Now, if you were the mathematician in charge hundreds of years, maybe thousands of years ago, that were, once they started realizing, wait, we got to undo these functions. We know how to add, but to solve something, I might have to subtract. I know how to multiply, but one day I might have to divide. And all of a sudden, problems start to surface. Okay, like I can multiply by 0, but can't divide by 0. So inverse functions maybe aren't as wonderful as they seem. They can be very tedious. It's the first one you've seen where all of a sudden there was an issue. So now we're the mathematicians that get to pick. Okay, if you got to pick, and I said, well, we've got to square root some things, so we got to decide. Are we going to take the inverse of, this arm or of this arm? Because if I take the inverse of the yellow arm, I get this. If I take the inverse of the green arm, y'all can barely see that green, I'm sorry, you get this. Okay? Does everybody see I can't have it both ways? That's why when you put into your calculator today, which spherical is what was decided hundreds, if not thousands of years ago, still holds true with our computers more than it ever did. If you put square root of 25 in your calculator, what's it going to say? It's going to say 5. So it's all still there. Somebody has chosen for us. They go, wait, it's not a function, so I got to pick part of this and still try to help myself make it work, okay? So what would I do, what would everybody do if I asked you this? X squared equals 117. We would get our calculator and say square root of 117. But then we also give the negative answer because we know what function we're on. Look at my eyes. Okay, I'm on the x squared function. I'm not on the square root function. But what's my calculator going to think I'm doing? If I punch in square root of 117, it thinks I'm on the square root function because it doesn't have a brain. I have to know what I'm doing. Okay? All right, so we got to pick one, green or yellow. If you were like some people that I teach or know, and you were just like intentionally aggravating, like Mr. Hill, which I would wish he was here so he'd hear me say that. If you're intentionally aggravating, Mr. Hill would go. If you've ever had him, you may have ever had Mr. Hill? Okay. So he would go, let's pick the green side. Which side are you going to need the most? If you're going to program calculators and you want to answer questions, most likely you're going to need which side the most? You're going to need the yellow side the most. And so it's a kind of a no-brainer decision to take this yellow side, reflect it over the line y equals x, and switch all your x's and y's, and come up with this. And then don't we just sort of manage this side on our own when we're thinking? So when I see this, okay, my first thought is 5. Yours too, probably. But then you got to think, wait, this has got 2 answers, one here and one here. So the answer to this question would be 5 or negative 5 because you're on this function. 5 gives you 25, negative 5 gives you 25. Okay? If I ask you this, girls, you're on this. You're on this. You're only on that, and what is the only answer to that? 5. Okay? You might remember a day that we talked about this earlier in the year. What is the answer to this? It's 1, for sure, isn't it? So you must believe the square root of 16 is 4, and I just stuck a minus sign in front of it. What is this? 9? 100% for sure. Because the square root of 16 is going out 16, and you want to know what the square root of it is, which is 4. No, this one is 1. That's what I'm just like so adamant about this, because where you got confused is when somebody did this to you. I don't know if we've done this before. 3x squared equals 12. Then you divide it by 3, and you got x squared equals 4. And then you square rooted, and all of a sudden a teacher says plus or minus 2. That's not true. Have I not done this with you? Oh my gosh. Everybody get out their calculator.
Wait, what?
Go to y equals. That's why you're confused. I used to wonder why I was so confused about it. And I was some people's algebra 2 teacher, okay? So I'm not pointing fingers at anybody. Here, I'll also give you this. See, she's going to make you a point. Ginormous point. This will be very eye-opening. I'll be like, oh my gosh, you're kidding. Okay? But with an algebra 2 student, especially an algebra teacher in the 9th grade, there's an academic maturity that would not have been true to. I try to explain it in algebra 2 class, but a lot of times they don't grab it. But you'll grab it. I want everybody on your y equals, first of all, hit Zoom 6 to get on the standard viewing window. Okay? Go to y equals Zoom 6. You got it? It just gets you back to negative 10 to 10 in case you weren't on that. Okay? That gets you squared back up. It's really rectangular back up, but anyway. Okay, is everybody ready? Go into your whiteboard, clear everything out. I want everybody to type this into your whiteboard. I think on your calculator, when you hit the square root button, does it come with a parentheses?
No.
Anyway,
Mine does.
you want this. Just make sure the square's underneath the square root. Okay, don't do anything else. Does everybody have that in your calculator? Push graph. Thank you. What is that? Absolute value of x. So what you did not see, which was kind of sad because now all of a sudden you feel like that you're trusted, and for Katie, Lily, Danielle, I think that's it. Your trusted algebra 2 teacher was all of a sudden saying the square root of 4 is plus or minus 2. It's not. Okay? I shouldn't have said that, but we needed to keep moving. So now you're going to know what's happening. Hang on just a minute. Hands down. Watch this. Work this with me. And girls, listen, before we go on, let's talk about why you were seeing this picture. For the rest of your math career, whenever my students see square root of x squared, you're going to remember that picture, I hope. You're going to go, that's not x. That's absolute value of x. What is the answer to this? Order of operation.
3.
It's 3. Okay? Because it gives you the square root of 9, which is 3. I think you believe me. If I type that into my calculator was programmed by very smart people, and it'll give you 3. It's the right answer. Okay? Let's keep moving. Okay? And so we'll get there. If I say the square root of x squared, what's the answer to a square root? It's always what? Square roots are always positive, or what are they? Aren't the answer to a square root is always positive. This is the square root of x graph that you played around with your transformations. Correct? Okay? The answer to a square root is always positive. We'll get, the reason why I don't ever give the negative is because it's not a function. Okay? So they had to pick one. We can't program things into our calculator or work with things that don't function. We have to find workarounds. Okay? So Grace Murray, Grace Hooper, if I say Grace, I got to find a workaround. They got to know which one I'm talking about. Okay? So that's answered your question. Now, if I square 3 and then square root it, doesn't it return 3? So if I put in a positive and I get back a positive point for point, do y'all see that side? But if I put in a negative and square it, what does it turn it into? I get the same thing. Okay? You get the absolute value of x. So watch me work this problem again. Okay? Inverse functions. I would subtract 4, and then I would add 4. Right now, Do you know I'm not worried? I'm not on guard. I'm not worried because addition and subtraction don't have any problems whatsoever. Do they? They're one-to-one functions. Okay, if I add 4 plus 2, I get 6. I'm sorry, it's a really bad example. Let me show you what I mean. If I have x plus 3 and x minus 3, x plus 3 looks like this, x minus 3 looks like this. They flip over the line y equals x, and everything's a function. There's no problem, and you've probably never been tense about adding and subtracting. You are a little tense about dividing because you can't divide by what? 0. So do you all of a sudden start to see with some functions, when you do the inverse, there's some disclaimers that come with it? Oh, but you can't do this, okay? But I'm okay dividing by 3, would y'all agree? Whenever you square root, you should be tense. But this is what's happening. Square root. Tell me what this was. That is not x. You just saw it with your own eyes. That is not x. X could be positive or negative. Couldn't x be negative 5? Okay, what did you see on your screen? Absolute value of x is equal to, what is the square root of 4? 2. Okay, the square root of 4 is 2, will always be 2. I know you got confused because of somebody skipped, myself included, the step I just showed you. The square root of 4 was never plus or minus 2, but once we started saying that, you're like, oh my gosh, I don't know which one to say. It's not your fault, okay? The square root of 4 has always been 2. The square root of x squared has always been the absolute value of x, because the square root is always positive. And what could you put in there to make that true? What could you put in for x to make this circled statement true? That's where it's coming from. Your plus or minus was traveling down this side. Your plus or minus wasn't traveling down this side. Okay? So that's why you're confused. Because somebody all of a sudden said square root of 16 is plus or minus 4. Square root of 25 is plus or minus 5. In the context of solving the problem. And then your teacher steps away and gives you something like 8 plus square root of 25 and expects you to know that's 5. Do y'all see what I mean? Maybe. You'll have to think about it. You can process it, okay? But what can I put in here to make this statement true? I could put in 2 or negative 2. So I need to move on, but let me end this with this little part of the big part of the conversation with saying that the square root of x graph looks like this. The square root of 25 is only 5. If I have x squared equals 25, and I square root both sides, this side is 5. What you didn't know is what this side was. Now you do. What's that side? That side's absolute value of x. And so what could go in the left-hand side? 5 or negative 5. Okay?
X could be positive.
So technically this step should always be in there so that no students are ever confused. The answer to this question is 5 or negative 5 because you're on this function. The answer to this question is only what? 5. All right, so let me move on. That was a lot. Okay, so stay with me because we got to move really fast through the next part. Here's what I'm trying to say. If something's not a one-to-one function and we're about to flip the x's and y's, we're going to get a lot of repetition like a lot of people run winter track. A lot of people go to Boston College. Okay? So if we're going to switch x and y, we're going to have to decide what we're talking about. Like the square root function, when they flipped it over, it wasn't going to be a function anymore, so which side? You got to pick one to keep working with. And so they picked the positives, because guess what you're going to need the most? The positives. You can always compensate and override it in context of the question, and you'll see that this year. Your teachers have really never said plus and minus 5. What have they always said? Plus or minus 5. Which one's your calculator give you the positive one? But in a context later in the year, I might decide to pick the negative one instead of the positive one because I know what I'm working on. So I take that answer on these inverse functions with a grain of salt. Okay? I don't know which one that phrase means, but I take it with suspicion. I go, well, thanks for a heads up. Now I've got to think about what I want. Okay? So have your calculators out in degrees. And let's see where this is going. So, sine of 30 degrees is 1/2. Sine of 150 degrees, tell me what you get. Maybe even in your head, right? Because you're really good at this now. Sine of negative 210, punch it in if you need to. 1/2. Sine of 390, anybody? Okay. These are all functions. The sine wave's going like this. It is a function. Agreed? Oh my gosh. Is it going to be a one-to-one function? Heck no. It's going to be horrible, isn't it? I mean, forget the plus or minus scenario that we just spent so much time on. We've got a really bad problem here. To where when we're solving problems soon, and I need to know what the angle is, but I know the answer, I have a severe problem facing me. Don't I? I'm going to push inverse on 1/2. Is it even capable of giving me all of the answers? You'd never get to use your calculator. You'd go, please stop. Because how many things answer that question? Not just 2, an infinite. You would go, oh my gosh, I can't believe I just typed that in. So do you see mathematicians of old had to decide, okay, do you want 30? Do you want 150? Do you want me to name everybody that goes to the party? Do you want me to name everybody that goes to Boston College? Okay? So when I turn that, it's going to look like this. Do y'all see what's going to happen when I switch X and Y? It's not going to be a function. Okay? It's going to be horrible. So, we've got to come to an agreement together right now. So let's slowly graph the sine function. Or quickly graph the sine function. This is pi. This is pi over 2. This is 3 pi over 2. This is 2 pi. This is negative pi over 2. This is negative pi. All right, in red, I'm going to pick a sliver. You know how we picked a piece of the square root function? And if we weren't trying to be aggravating, we would pick the positive piece because that's what people need the most. I've got to pick a part of this graph that doesn't repeat itself. You know how with the square root function, I didn't want to pick the piece that went back up? I think your way would be this one. Okay? I got to pick a piece of this function that not only functions, but is also one-to-one. Like this arm of my square root graph is a function and is also one-to-one, isn't it? I can work with that and turn it over. Okay? I'm going to have to work with this and turn it over. I think I could pick a piece way up here. Is that what most people are probably going to need in life? No. That's where they're probably going to be. At least it's going to give me a reference angle, right? And I can go from there. If I punch in arc sine of 1/2, I think a lot of you know it's just going to say 30. That doesn't mean that's what I was looking for in context of the problem. I might have drawn a picture and I needed 150 instead. And I'll get you there. Okay? But I think, is anybody going to try to come up and draw on the yellow? Do you think you know the sliver that I'm going to pick? Come try it. She's brave. Be thinking of what you would pick. Look at you. That's awesome. Okay? Great. Is that what some of you were thinking? Like, I'd kind of rather go 0 forward, but that won't work for me for 2 reasons. I think some of us would kind of rather do like this way. But first of all, if I go all the way to pi, it doesn't allow for me to get any negative answers, and it's not even still going to function. And I think Isabel meant like not to get over the hump, okay? So when you're doing arc sine, of 1/2, you will do what your calculator does, just like I have talked so adamantly all class to really drive this point home. When I say square root of 25, I want you to understand what's happening, and you say 5. When I say arc sine of 1/2, you're only thinking what Isabel drew for us. You're only thinking about this sliver. If you're on the inverse function, you can't name them all, and you guess what? You don't get to all name different ones. You know, Brianna might go, I want 150, okay? And Lauren might go, I want 390. And Chloe say, I want negative 210. We're not going to get anywhere like that. At least let's all get the same answer and then go forward, okay? So somebody's chosen for us, and we're going to abide by it. This will allow for every ratio that I'm going to possibly encounter. Does everybody understand that allows for everything between negative 1 and 1? So when you go arcsine of 1/2, it's only going to say 30 degrees. Or pi over 6, whoever used radians. I can't remember who that was, okay? When you say arcsine, which is the same thing as this, your calculator will only say 30 degrees, and you should only say 30 degrees. Your calculator was right. Some of you thought you needed to override it and go comma 150, but if you think about that with me, if you're going to do that, you're never going to stop. I don't know why. I do know I'm being facetious. I don't know why you stopped at 150. I do know why you stopped at 150 because that's the first two you thought of. What are you supposed to name? The first logical one that people think of. Okay? So what's going to happen when I say arcsine of negative 1/2? Okay, so this is what we'll write on your memo page next class. Okay, let's don't do it today with the interest of time. But arcsine, Isabel walked up here and beautifully did this. This goes from negative pi over 2 through 0 to positive pi over 2. Like this around the circle. This is the only place that you can go with arcsine. Arcsine of x, where you're looking for an angle. You can only swing up to pi over 2 and down to negative pi over 2. So much so that I will not allow you to enter something like 300. Okay? The reason you can't go over here and go into 300, what you should say instead is what your calculator says is negative 60 on those coterms. So I got a minute to tell you this stupid story, but it always makes me think about this because it's something I did wrong. My friend Mary went to a neighbor's. She's kind of a mean lady. She was really scary. We thought she was mean, but you know we shouldn't have been in her yard picking her fruit. Okay. Now we knew if we got caught, and how bad did I really need that apple? I knew that. So Mary and I are like 6, and we're climbing over the fence, and we get some fruit, and we run back home, and we get under a tree, and we eat our fruit, and we pile up, feel guilty. Meanwhile, she calls my mother. Okay. And we have to go sit in the ladies' den and apologize to her. It's the most horrific thing, okay? And the deal was, is I was not allowed to go over here where the mean lady lived. If I wanted to get to Mary's house, was I going to go around this way? I don't want to do that. So how am I going to get to her house? I'm going to go down, okay? We'll get cosine and tangent following what Isabel did because they have different rules. And I will post a different homework than the one I planned. So I'm not quite ready for the bookwork, I don't think. But just, you'll see it when I post it, okay?
Thank you.
Definitely memo quiz.